So let's say we had a very simple data set like this, and we wanted to do an XY scatter plot of that. Um, Using Excel, we can just go and insert a graph and everything. We want to do this in Python. So what we're looking to do is plot X versus Y values, and we're going to use matplotlib to do the work. So what I like to do is I like to make my work easy for myself. So I use Copilot to do a lot of the work. And so even on a basic level, I can take this and there's some work that's required on your end, right? We can make a data frame or a list, and then we're going to a list for the y values and a list for the x values, and then we can use matplotlib to plot x versus y. So what I do though is I actually, to make everything easy, I'll just copy this and I'll put it into Copilot and tell it create a scatter plot of what I want. So this is exactly what I did. So I just copied and pasted the data set, and there we go, very, very simply. And you can see it even made the data set for me, right? So if I've got data here and I want to plot it, I can actually get it to do all the work for me. So here it is, putting it into a list for me for X and a list for Y. And then there's the scatter plot, X and Y, X label and Y label and plot. I can change the limits if I want as well. But at this point, I can copy and paste this and put it into my into my Jupyter notebook and see what happens. So I'm going to copy this. I'll move this out of the way here, and we will get our pandas data frame going. Or sorry, well, we got our Jupyter notebook going. So I'm going to paste in. I'm going to do Control V to just put it in. And one thing that's important to do, save this right now. So I'm going to save this. I'm going to call it scatter basic and rename it. The reason why I do that is because sometimes when I hit run here, and if I haven't saved it, the browser will crash and all the information I've got will disappear. So let's see what happens when we do this. So we're going to import matplotlib. There's no math being done. And so just on this data set, we're plotting it. I just created some random numbers here. That's all I did. And there it is. So what we're looking to do with a scatter plot is we're trying to define some sort of x variable and we're trying to define a y variable. And for our data sets that we're looking at, so let's take a look at our data set. Let's say, for example, we want to plot lab day versus mass salicylic. So we've got a lot of data, but I want this to be my x variable and I want this to be my y variable. And so we've got a lot more work to do here than just creating these lists. We need to call in the data, the gigantic data set, as a data frame. We need to specify that this is our x value or y value here, and this is our x value. In fact, we can even group the functions, we can take the means and standard deviations, and so we can go much more advanced than what we're seeing here. And that's what we're going to do in a few of the examples that I've got coming up. We're going to start to add on some complexity. So for the next video, you're going to see we're going to call in and create a data frame from that data file that we've got, and we're going to start plotting XY data in a scatter plot fashion. So one simple one I just want to show here is we can set the limits. It's already at 0 to 10, but if I wanted to, I could set limits here. I can change what the spots look like as well, but if I wanted to plot Y limit, and I want to go between 0 and, what do I want to go between? 20, let's just say. And if we rerun this, hopefully we'll see that the x-axis changed, or sorry, the y-axis changed up to 20. Whether that's useful or not depends on what you're looking to do. I can go back to 10, hit run, and see that. But you can manipulate the data. It looks like the starting point is actually at like -1. So let's go -1. That's what the original one looked like it was at, so it could actually show the 0 point. And so this is our starting point for graphing scatter plots, which we're going to use significantly in our science data analysis. So we want to start visualizing our data, and we want to use a scatter plot to try to see what's going on. So we have our data set called in here, and we're just taking a look at it. So what we got lots of columns of information here. We got year, we got lab day, we've got some continuous data here, mass of salicylic, acetic anhydride, and whatnot. and we just want to see what this looks like. So the easiest way to do it is just plotting a column versus the index here. So if we do that, we're just going to see what this looks like over time. Because as you can see, we want to plot this variable separately from this one, from this one, from this one, and we want to see just what it looks like. If we were to do it just based off of year, we're going to see that we're going to have one X value here of 2023, and we're going to have a whole bunch of mass ones. So we'll see what that looks like as well, but we just want to see what each individual one looks like on its own. So if we go to the new notebook here, we want to import pandas as PD, and we want to import the matplotlib so we can visualize it. Going to read in our CSV file here, so create a data frame out of it. And then all we want to do is plot. So we're going to use the plot function from matplotlib. We're going to create a scatter plot. And so we're going to then use the data frame index. So this is going to be the X axis right here. So the X and then the Y axis. So all we got to do is for the scatter plot, we got to define an X axis and a Y axis. So X comma Y. So df index is going to be what we want for the x-axis, and then the data frame mass salicylic column, that's it. And so just for some labels, we'll put a x label as index and the y label as mass salicylic, and then we'll show it. So let's see what happens if we run this. Hopefully something. And there it is. So this is just generically our mass of data over time. So this is from every single student data point from 2017 all the way until now. And you can see for the most part, everything is pretty consistent. Remember, this is just weighing out. In this case here, this is your starting material. It's supposed to be about 5 grams. And you can see everyone along the way is pretty good. But there's a lot of kind of errors out here that we can start to see. So if we wanted to, we could, starting our journey, we could filter some of this data, we can remove some of these, but we don't know why we should be removing them. We can kind of infer what it is. Obviously, this one here is way too low, and it could be that either they dropped some or something that got stuck somewhere. This one here looks like they added in the Wayboat plus the material, and so this is the Wayboat plus material. This one could be just the Wayboat itself afterwards, and they inputted the wrong data point. Some of these now we actually just don't know. So getting rid of some of these data points, like I said, historically it's difficult to decide how to remove these, and we kind of need them in here to work with this. So let's say then that go back to this data set here. Okay, we got this idea of this, but it was almost too much data. So what can we do with it? Well, let's plot it versus, say, lab day. See what happens if we do it versus lab day, and maybe it'll sort of categorize the data. We can actually see lab day from lab day, who's better, who's not. And so we go back to here, and so we're going to import pandas as a PD, matplotlib again. We're going to read in our data frame once again. Now we're going to group the data by lab days. So we're going to create a variable called grouped. And now when we do our scatter plot, the X variable is going to be the grouped lab day. So that we've got there. And then now the Y value is going to be the grouped mass of salicylic, and the label for it is going to be named. So that we're going to have a label here we can put into a legend. So the X label then we're going to have is lab day, the Y label mass of salicylic. The legend is here on the side, it's overlapping everything, and we could change that. We could actually say where we want the legend, and then when we plot it, this is what it looks like. So we can see we're getting, except for the legends in the way, we can see more mass of data. So this is all the students on the same day, all the students on the same day, and we're going to start to see there's very little variation out of this one where we get to this. We've got on the same lab day, someone inputted two different spots. So on the previous one, it looked like it was two different spots here. It turned out this was in the same lab day, and now we can get better visualization of what's going on. And so maybe we can make a better decision to remove these. It could have been the same person doing this by accident twice. And then we can see the spread here as well. So there might be more information we want. So rather than seeing this entire data set like this, maybe what we want to do is just get the mean. So instead of seeing this entire spread here, let's just get the average of each of these and plot that on a graph and see what that looks like. So what we'd like to do here then is during this group by function here, we want to add on to it so that we're going to work on this column and create a mean. So we're going to kind of add this bracket on and then put dot mean. We're going to be able to get it all into one function. And then when we plot, we're going to plot the group lab day based on this group right here. And then we're going to get a new sort of y value here based off of the mean. So we're going to see that this is going to expand here, and then the variables for x and y are going to be related to this newly expanded version. So using ChatGPT / Copilot, I was able to create this function. So here we go, code. So we imported pandas again in matplotlib. We read in the file, and now we want to group by lab day. So it's the same thing. We did the group by lab day. So this is pretty much the same as what we did before. So let's take a look at that. Where did that one go? Nope, right there. So df group lab day. So we're df group lab day again, but all we've done is right here we've added in, I also want to get for this specific column, so this column right here in square brackets, I want to get the mean of it. So every lab day, get the mean of it. And so now all in one variable here, grouped means, we've got all this information. So now we have to plot it. So to plot it then, we're going to group the means by index, and so the new index that we've got is based on A, B, C, D, because we've grouped it by lab day. That's kind of our new index again. And we're going to group then the mean values, so the values that were determined here. So this is a bit different than what I would have done. I've got another version of it that I've asked for Copilot, but this is the plot. So this is exactly what we were kind of looking for. It's not as messy as the previous one. So here is the what this looks like, but it's every single data point. And so what we wanted was the average of the data points. And so now this is what we're looking at. So we can see there's a drop down here and it goes up. Now note also these values, the x-axis and the y-axis here, the x-axis determined by lab day, but the y-axis is actually quite limiting. We can change this if we want to by putting on the plot here, we can put x limits and change it from 4 to 6 or something so that this variability doesn't look so bad. And so you can do the data manipulation whatever way you want to make the data look worse or better depending on what you want. So let's try it a different way. So it's very, very similar. We're going to group by as well and get a mean of it. But we'll see that we're not going to use the group means. We're going to re-index everything over here. So let me show you what this one looks like. So we're going to read in pandas or import pandas in matplotlib. We're going to read the data frame as df, and we're going to group the data again. So they just changed the variable name, but they're still group df, group by lab day, says exact same as the last one. I want to calculate the mean of the mass of salicylic, and we're going to reset the index here. So I'm not exactly sure what this does, but I could call it in a Copilot and find out exactly what this does. But it's multiple functions. So the group by is a function. This mean, anytime I see this closed and open bracket right here, this is a function. So this um, blue thing here with the closed and open round brackets is a function. This one is a function, and this one is a function. So you can see that we're adding function after function after function in one row here. So that's pretty powerful, I think, in Python. So once we've got all our data is in here, so we've got group by lab day and we've got the mean of the salicylic, now we're going to plot it. So we're going to plot the x variable is going to be the group df, specifically lab day. So that's going to be that column there. And we're going to group the y values based off of mass salicylic. So from the group df mass of salicylic right there, that's what we're going to do. And so if we take a look here, we plot lab day versus mean mass of salicylic. We even have a title in here now. The plot's exactly the same as the other one. I'm not sure if the index is or the limits are the same or not. Yeah, they are. So the plot's exactly the same, right? So we get the same result. And it could, depending on how you ask ChatGPT or Copilot how to do this, you can get different results. And of course, you can go to the internet and find out information as well, and they may have different ways. But I like this very simple format. You're doing a scatter plot. I want X and Y values. And so we just need to make the X and Y values using this function right here. So that's pretty much it. One last thing we'd like to add on to here that would be useful is error bars. So I've got the mean here like this, but we can also get the standard deviation of the mass of salicylic, and that would provide some really nice information for each of these points. What kind of standard deviation is occurring with each of them? So let's do one more scatter plot. We're going to add to this essentially, and we're going to put in error bars, Y error bars that have the standard deviation as the error. All right, so we've added in some error bars here. So all we're doing is the exact same thing. Import pandas as PD matplotlib, read our data frame. We're going to group the information, and notice that we've got the reset index here now at the end of this, but we've got both the mean and the standard deviation that we want to calculate. So under the grouped variable, uh, we're going to use on this data frame we're going to use the group by function based on lab day. So we're going to group everything by lab day, and then what we're going to do is we're going to aggregate. We're going to create two different things. We're going to work on the mass of salicylic, and we're going to do the mean and the standard deviation. So that's some real complicated number of brackets here, and then we're going to reset the index. There seems to be no way around this. I've got another version of it here where the reset index is not on this code, but it is over here when we plot the graph. So you're going to see that this indexing seems to be required in order for us to do that. It could be because the index is originally based off of this pandas data frame, which has 400 or 200 some on data points, and maybe we need to reset the index just based on the group of lab day with this. I don't know. I'm not really sure, but we can go to Copilot and find out. The fact is, it works. So, so this is the output then, and we can see then we're getting the exact same graph. The only difference is now the axis has changed. So the axis has changed because the error bars here have gotten so great that in order to actually see them, we need to have the axis larger. And if we really wanted everything to be the same, we could actually try to limit the y-axis here. So what I'd like to do is before we show the plot, I want to limit the y-axis. So I'm going to do a y limit here, and let's go between 4 and 6. So what that's going to do is it's going to start at 4 and finish at 6. It might not actually do much of a difference here. So we can actually change these values and see what happens. But there we go. We see the full error bars now. We're going from 4 to 6. If we wanted to, we could just go from 6 instead of 6.00 and see what happens. So exact same thing. So let's go back to our other scatter plot, one of the ones we just had previously here, and see what happens if we change the limits here. So the y limit, and I want to go between 4 and 6 again, and we'll see what happens here. You can see it almost looks a little more straight. So the data is exactly the same as we visualized previously. It's just the axis really plays a role in how we see it. So here's this one, and then we're doing this one with the error bars on it. So exact same data set like that. So the variation that I told you about then was where this reset index is now part of here. And you can go either way with this. Like I said, I use Copilot to help me out, and each time I do it, there's a slight difference in between. So pay attention to what's going on, why they're doing it, and learn from it. That's the biggest thing. That's what I'm trying to do. So we're importing pandas, import matplotlib. There's our data frame again as usual. We're going to create a variable called grouped. There's our data frame. We're going to do the group by function on it to organize by lab day. And then using the column mass salicylic, we're going to get the mean and the standard deviation. The indexing is not here. The indexing is over here. So when we're doing the error bars, it looks like that's where it wants to index the information. So we're going to create a plot between 10 and 6. So that's the size of this plot here. The error bars and the mean are going to get all plotted on here like this. The format for for these dots is an O. We can change this to X or something as well. So the format of what this looks like, and you'd have to Google it to know specifically what to type in there. So this is going to be lab day at the bottom, mean of salicylic acid on the side, and then our title here says scatter plot. And again, if I wanted to change the limits, I'll do a Y limit, and I'll do it between 4 and 6. Oops, I need a comma there. We'll run this, and we'll see that the data set then gets between 4 and 6. And we compare the two, we should see they're pretty much exactly the same, and the data was the same. Notice that when I like using this group by function, I find it very clean and easy to understand. If you don't specify, if you're using Copilot or AI, if you don't specify the functions you want to use, it'll just use anything. So if you know what you want, make sure that you type it in, that you're actually using group by, um, sort by lab day, and develop the mean or create the mean and standard deviation for the mass of salicylic acid column. And this is the function that will come out of it, the code that will come out of that. And it can slightly change again depending on what it's feeling like today. I didn't ask it to do reset here. I didn't ask it to do reset index here, but it did. So be careful of what comes out of it and the slight changes and variations that occur along the way. But this is a really straightforward way of kind of visualizing our data using a scatter plot, and something that we're going to be using a lot in our work.